Here we are back, Chapter 4, Unit 1. We are going to wrap up the solving by factoring today. We'll keep using it throughout the year, next year in pre-calc, but we're going to be done covering solving by factoring after today's lesson. So, today you'll be able to solve equations in the form 0 equals ax squared plus bx plus c, as promised. We're back in 4-4, where a is going to be some value other than 1. And be able to find the zeros of an equation in the form y equals ax squared plus bx plus c. Now remember, finding the zeros, solving, they mean the same thing. We went over this yesterday. So really, two goals once again. Do I need both of them? No, I probably could have said be able to solve equations, find the zeros, x-intercepts, all of it in one. So hopefully you're starting to see that. So just again, remember, these four terms, they all mean the same thing. Solutions, x-intercepts, zeros, roots, we just covered it. When if I ask you to do these things, we're doing the same process. We're solving for x. We're setting the equation equal to 0 and solving for x. You cannot solve by factoring if the equation is set equal to 0. We're going to see that come up here in this lesson. Okay? So, zero product property. It says same as Friday, but obviously I don't know what day it is that we're doing this, but it's the same as the previous day. This is from an old slide here, but if the product of two expressions is 0, then a times b equals 0, and a equals 0 or b equals 0. We're going to use the product property again. So, just like yesterday, here's one that's already factored for us. 3x minus 2 times 4x plus 5 equals 0. If we use the zero product property, we can think of this first, what will happen there? This first binomial as A, and the second as B. And we have 3x minus 2 equals 0, or 4x plus 5 equals 0. And just like we did yesterday, we solve for x. Now, the wrinkle is these are two-step equations. Still Algebra 1 stuff. You solve 3x minus 2 equals 0 a ton in Algebra 1. You probably even did it in geometry, at least sometimes. And probably before algebra. So you've been doing this for a while now. The key to solving two-step equations is we undo the addition part first. Yes, undid subtracting 2. We reverse the order of operations. We reverse PEMDAS. So please excuse my dear Aunt Sally, that deal. We start with parentheses, exponents, multiply, divide, add, subtract. When you're solving an equation, you reverse that. And you start by undoing the addition and subtraction first. So that's why I added 2. And then 3 is multiplying x. You undo multiplying by dividing. And so we get x equals 2/3. Subtract 5 from both sides over here because 5 is being added. That's where we start when we solve. 4x equals -5. Divide both sides by 4. X is -5/4. So, two-step equations. Do we have integers like we had yesterday? No, we have fractions. But you're going to get irrational roots as well, ones that can't be written as fractions. You're going to get square roots as answers. Those are irrational numbers. So, it's going to happen. Not every answer in math, unfortunately, is nice and neat. Now, we can check this by plugging these values back in. 2/3 times 3, well, that's going to be 2. 2 minus 2 is 0. That makes the whole thing 0. We're good there. -5/4 multiplied by 4. When we plug it in, it makes -5. -5 plus 5 is 0. Also works. So that's how we check it. Plug it in, graph it. Multiple ways to check your solution. Always check, always check, always check. So, solving 2x squared minus x minus 21 equals 0. Looks very similar to what we did yesterday. The only difference is the number in front of x squared is not 1. Okay? So, in all of these, whether you're solving, whether you're finding the zeros, you have to set y equal to 0. So the whole equation has to equal 0. In this case, it already is. So that's step 1. Step 2, before we start factoring this with bottoms up or anything like that, always check for monomial terms. 2 is a prime number, and we have a -1 in front of x. We're not going to have common divisors other than 1. And x is only in the first two terms, so we can't pull out an x either. So there's no monomials to pull out, so we go straight into bottoms up. Seems like we've been doing bottoms up for a while, hasn't it? Now you know why we took so much time practicing bottoms up, so this is second nature to us. I hope. 2 times negative 21 is negative 42. So what multiplies to make a negative 42 and adds to make negative 1? I want you to pause this, try it on your own, see if you can find the combinations, list them out. Okay, and then when you're done, come back and hit play. Okay, did you find the combination? The combination that I got was negative 7 and 6. They multiply to make negative 42. When you add them, they add to make negative 1. That's our winner, winner, chicken dinner, as we like to say. That's it. So, we plug it in. Our variable is x this time, so x minus 7 times x plus 6. And we set these equal to 0 when we solve, right? Why is that not right? Well, in order for us to set the term of factors equal to 0, it has to be factored properly. X times x is not 2x squared. I can tell that right off the bat. So what are we missing here? What do we have to do? We have to divide by a. This is the bottoms up method. Divide by a. A in this case is 2. So yesterday in 4.3, all the solutions, they were nice. It was 1x squared. It was dividing by 1 for all these. So they were factored when we got to this point. And then this equals 0. So we have to go through this process. 7 over 2. Put in your calculator. It won't reduce. I think we've done this one before. So the bottom part comes up. And we get 2x minus 7. Was that factored? 6 divided by 2 is 3. So that reduces. Now we have factored form. Please, I'm not going to do it this time. But just because I'm not going to do it now doesn't mean that you shouldn't. Go back and check and see that you factored this correctly. The quick way, graph A, the equation we started with, in Y1, graph this in Y2, and make sure that they have the same picture, and when you go to the table, the same Y show up in Y1 and Y2. It's a quick way to check it. It's worth it. Okay? I know it takes you an extra 30 seconds to do that, but I'd rather make sure I did it right at this step than to get all the way through and realize my answer's wrong, and where do I go back? If you realize you factored in correctly here, you know where to go back to at this point before moving on. So please, please, please do that. If you forgot how to get it on the graphing calculator, go back to previous lessons I showed you in that and look that up. Okay, that's the beauty of having this online. You have all these resources for you to use at home. So 2x minus 7 times x plus 3. We're going to use the zero product property again. 2x minus 7 is 0, and x plus 3 is 0. What do we do? If I look at this one, I have 2 times x, and I'm subtracting 7. What do I undo first? I undo the subtraction. How do I undo subtracting 7? I add 7 to both sides. So I get 2x equals a positive 7. Divide both sides by 2. X is 7 over 2. Over here, a little bit more straightforward. All I have is a plus 3. I subtract 3 from both sides. I get x is negative 3, and x is 7/2. Do I take my word for it? You take my word for it? No, we should check it. And to show your work by checking, you have to show plugging it in. Okay, now obviously, if it's a multiple choice test, graph it, see where it crosses, plug these in to the calculator, see if you get the answers. But I just want to show you once again how I would plug these in by hand in case I don't check every single one. I expect that you will be checking them. So when I do this, 2 times 7/2 squared minus 7/2 minus 21, this is really all I'm going to expect you to write down. At this point, you can go to your calculator. Okay? That's the calculator's for. When we start getting fractions as answers, then this is what we do. This is what I would do. 7 over 2 squared. I can put it in like this. I don't have to do the math fraction part, but I can if I want. That 7/2 is a fraction. If I do alpha y equals, remember that gets me the fraction app. So I can hit 7 over 2 this way. Doesn't matter to me which way you put it in. Nope, either way will work. And then we subtract 21. We get 0. Hip hip hooray, we got 0. So we put that out there to show that's what we did. We get 0. So 7/2, that checks. What's the other answer that we need to check? We need to check -3. So 2 times -3 squared minus -3 minus 21. The beauty about putting it in your calculator like that, you can go up and enter, if you have one of my cool 84s, and we can just delete these terms. Oops. It might not be as easy when you have a fraction. There we go. And oops, I can insert as well. -3 minus a -3. And I like to put them in parentheses too. So I'm going to insert a parentheses. If I second delete, I can insert terms to that. That's pretty cool too. Insert a parenthesis here. Might have been just as easy by the time I get all said and done to just retype it, but sometimes this does save you time by just hitting enter on a previous term, and you don't have to type the whole thing in. You just have to change the values you're plugging in. So now we're plugging in a -3. Let's see what we get. We get 0 again, which is what we wanted. So we can go back up and say that -3 checks as well. So you should always check your answer. The other way, the faster way maybe, is, some people think it's a faster way, some people don't. We go back to y equals. We're going to put in 2x squared minus x minus 21. Graph it, maybe. And we can see 2 spots where it crosses the x-axis. 2 ways to check it. If I already have the answer, 7/2, I hit second trace and go to value, and I just type in 7 divided by 2. What's it give me? It gives me y is 0. Changed it to 3.5. If you type 7 divided by 2 in your calculator, you get 3.5. And I can also type in -3. So if I get an answer, I want to check it. Here's a real fast way to do it. If I didn't get an answer, I get stuck and it's a multiple choice test, I can always go to the 0 function. I'll show you that one more time. Left bound, it's blinking by this answer, right? So I just have to go above that point. That's left of it. Right bound, I have to go below it somewhere. So the 2 arrows are pointing at each other. That's telling the calculator to look between these 2 arrows. That's where the answer is. Can I get -3, 0? If I want to get the other 0, then of course, what I have to do first is I have to get over closer. So I just arrow over towards this one until it pops back up. The screen should be coming any time now. Where are you? And just take some patience. That's why sometimes it's better to put the y equals 0 and y 1, and you don't have to worry about that so much. But I didn't, so I just have to be patient. So somewhere there, it's as close as it's going to get. It says 3.5, which is the same as 7/2. Okay? So there's a couple ways to check your answer. Well, make sure that they're correct. And even you can solve it by graphing that way, couldn't you? Instead of even factoring. That would be one way to do it, especially on a test. But right now, we need to practice our factoring. So we're going to do it that way. What if we get a problem like this? 4r squared minus 18r plus 24 equals 6r minus 12. Let's think about that one for a minute. What would you do? Well, as I mentioned earlier, you have to have the equations set equal to 0. Nothing equals 0 in this one. So we have to manipulate the equation. So if you have variables on both sides, unfortunately, and I know this is something that's not everybody's favorite thing to do, we have to move the terms over from one side to the other so that we have just one expression on one side and 0 on the other. So 6r is a positive. I'm going to subtract 6r from both sides. 12 is a negative. I'm going to add 12. Now, somebody's saying, well, couldn't I have moved these 3 terms over? You could, but here's something to keep in mind. When you're factoring, I want to manipulate it so that whatever my squared term, in this case it's a 4r squared, I want that to be positive. Factoring it when it's negative is possible, but you run into a lot more issues, and it can get tricky. So I manipulated to make sure that my squared term, my squared variable term is positive. That's why I chose to move everything to the left. Plus, there's only 2 terms to move here versus moving 3. Could you have done it in 3? Yes. To me, this just is an easier way. So that's why I do it. If I think something's an easier way, that's what I'm going to show you how to do. So now it equals 0. Now can we factor and solve? Yes, we can. Now let's look at this. Remember what I always tell you before we start doing bottoms up. Always look to see if there is a what? See if there's a monomial term that we can divide out. Is there a common factor? A GCF, greatest common factor. Remember that term? So 4 is the leading coefficient. These are all even. That's a good sign. That tells me that at least 2 can be divided out. But is there a number bigger than 2? How do I figure it out? What is that? Whatever your smallest coefficient is, or the smallest number you see, start with that one. 4 is the smallest. We know 2 will divide 4, but 4 will also divide itself. Will 4 divide these other 2 terms? Check in your calculator. You come back, see if it will work. 24 divided by 4, 36 divided by 4. Does it work? Do you get an integer? It does work for both, doesn't it? So here's a cool thing we can do. We can divide out by 4. So we're factoring. We can pull this 4 out. And really solve it, we can divide both sides by 4 and completely get rid of it. But I'm not going to do that because I just want to show you that it stays there. Because we get in that habit, it can be a bad habit if we have a variable that can be divided out as well. So when I divide everything by 4, I get 4 divided by 4 is just 1r squared. 24 divided by 4 is negative 6. 36 divided by 4 is 9. How do I know I did it right? How do I know it works? When I distribute this 4 back through, I should get 4r squared minus 24r plus 36, and I will. Go ahead and try it if you don't believe me. But FOIL it back out, or in this case, distribute it back out, you should get it to work out. So, now, we have a trinomial inside the parentheses. Can we factor that? I think we can. I think we can, and we will. So, you might notice that this looks like it might be a special pattern. Maybe you don't. But we're going to use bottoms up on just the r squared part. Just this part. That's all we're going to do. This 4 is off the side. We're not going to worry about that right now. A times C, 1 times 9. B is negative 6. So what multiplies to make 9 adds to make negative 6? I mentioned special patterns. This looks like a perfect square trinomial to me. So hopefully you think about it. What would the possibly be? 3 and 3 or negative 3 and negative 3? Has to be negative 3 and negative 3 because it's a negative 6. So indeed, negative 3 and negative 3, that is my solution. So what's this going to factor to? R minus 3 times R minus 3, or R minus 3 squared. But we're solving, so we want to keep them separate. So what are our solutions here? Well, we take each factor and set it equal to 0. 4 we factored out, but does 4 have a variable by it? It doesn't. So when we set this up 4 equals 0, does that make sense? No, it doesn't. So if we factor out a number, we don't have to worry about it. There's no variable in the term. You don't have to worry about setting it to 0. There's not going to be a solution. There's no solution for that. So 4 is just kind of an extra term here. Now if it was a 4r, then we could solve it. We'd have r equals 0. But it's just 4, so that goes away. We have r minus 3 equals 0, and we have r minus 3 equals 0. It's a repeated solution. We add 3 to both sides. We're going to get r equals 3 for both, right? It's the same thing here and here. So r equals 3 is our only solution. You take my word for it? No, we plug it back in. Now, we plug it back into the original equation. You plug it into 4 times 3 squared minus 18 times 3 plus 24. You're going to get a number. Plug it into 6r minus 12, get a number. If it's the same number on both sides, it should work. So let's do that right now just to practice it. What is he talking about? 4r squared minus 18r plus 24 equals 6r minus 12. If we're checking it, we plug in 3. We only got one number to check. We're going to plug 3 in on each side. If we did this correctly, we should get the same number. It should be plus 24 on both sides of the equal sign. Let's erase that. A little bit neater. So I'm going to put a question mark. Does it equal 6 times 3 minus 12? So you can put this in your calculator. A lot of numbers there to do. So a lot of big numbers, I guess. 4 times 3, we're going to put 3 in parentheses just for practice and habit, times 18 times 3. And also helps us know what we're plugging in here. It reminds us we're plugging 3 in for R in this case. We're going to get a number here, 114. Oops, I didn't plug. Oh, let me see where my mistake was. Every once in a while, Mr. Coon makes a mistake. First one of the year. Okay. I put a plus 18. Should have been a minus 18. You're probably all thinking, why did he plus? Just to see if you're paying attention and awake at home. So minus 18, let's try that again. That looks to be a little bit better. We get 6. And we need a calculator for this one. 6 times 3 is 18. 18 minus 12 is 6. You're probably thinking, well, he went, maybe he should. But we get the same thing on both sides. It checks. That means 3 is our only solution. Okay, last one we're going to finish with today is just a reminder of special products. Sometimes we have special products. We kind of did that already with the perfect square trinomial on the last one without even noticing. But I like to point out the difference of squares because this one is, you can do it by bottoms up, but if you notice the difference of squares pattern, it makes your life a lot easier to just do it this way. So I noticed that 81 and 169, they possibly could have some, they could possibly have some terms that they could factor out. But 81 and 169 is, or are, excuse me, perfect squares. 9 times 9 is 81, so 9t times 9t is 81t squared. 13 times 13 is 169. Now, possibly could we divide stuff out? Possibly, but I'm noticing that 13 here, that's a prime number. That tells me that there probably aren't a whole lot of other factors that are going to divide 169 other than 1. So we can combine these together. 9t minus 13 times 9t plus 13. Or could we do bottoms up? You could do bottoms up. You would have to put a 0 plus 0t term in the middle. So you have to say what multiplies to make 81 times 169 and adds to make 0. That's not as fun. You can do it that way, so that's why I try to train you with these bigger numbers. Look for the difference of squares and perfect square trinomials. Remember, we're not factoring it, so you should go and FOIL it, or you should take this problem, the 81t squared minus 169, and see if it comes out to be the same as 19 minus 13 times 19 minus 13, or plus 13, in your graphing calculator by graphing it and looking at the table. But check it somehow real quick. Once you verify that, now all we have to do is zero product property. I solved each of these. 2-step equations. Divide by 9. So I get t is positive 13/9. Put it in your calculator. It will not reduce. 13 is a prime number. But if you don't believe me, practice it anyways. That's good for you to practice reducing fractions on your calculator. So 13/9 and negative 13/9. I'm going to leave the checking for you. These are valid solutions. Go ahead, plug them back into the equation. Go ahead, graph them and graph the equation and use the zero function on your calculator. Use the value function on your calculator. Practice these. Make sure it works. Okay? I'm going to leave that for you to try. So let's circle back to where we started with our goals for today. We said we wanted to be able to solve equations of the form 0 equals ax squared plus bx plus c. I'm pretty sure that we added on with that from yesterday's lesson. We also want to find the zeros. I don't think we mentioned specifically today about zeros, but it's the same thing. I just have it as a goal. If it says find the zeros in your assignment tomorrow in class, you make sure that the equation set equal to 0, the ax squared plus bx plus c, you put 0 in for y, and you factor it, and you solve. It's the same thing. So I believe we've addressed these two goals. We're going to hone them in and practice some more tomorrow in class. Please bring your notes, especially with the targets here, ready for me to check first thing tomorrow morning or afternoon. See you tomorrow.